Okay, class, welcome to Math 2015, Learning Outcomes 7 video. And we're going to focus today on the various uses and roles of variables. Okay, so the idea of a variable is a number that is represented by a letter or a different symbol. And it could be any number or a certain number. And we're going to go ahead and kind of review from the reading a little bit about the different roles of variables. So the reading discussed 5 types of variables. 5 roles. So the first one, variables are used when generalizing patterns or properties. Okay. So one of the big steps from arithmetic to algebra is to generalize properties like the commutative property or the associative property or the distributive property. Behaviors like those in arithmetic can be generalized into those properties. And to indicate that we want to substitute in any number to the structure of these properties, we use variables. For example, the distributive property says that if I have some number multiplying a sum that is equal to the number multiplied by the first summed or first number added on to the number on the outside multiplied by the second number. Okay. Now these letters A, B, and C can vary. Okay. And they are different numbers, but they can vary. They could be the same, but they are different places. They have different roles. Okay. So the front number multiplies both the middle and the inside numbers, okay, using the distributive property. Another example of where variables are used when generalizing patterns is the associative property. So if you take any number and you want to multiply it by or add it to another number or to another number, so 3 numbers total, you can add them in any order. You can take the first 2 numbers, then add on to the third. It's just the same as taking the second 2 numbers, the second and third numbers, adding them together, then adding on the first. Okay? So to show that any number can be used, we use a variable. Okay? So in this case, A, B, and C can vary and be any number. In this case as well, A, B, and C can vary and be any number. Number 2, variables act as fixed placeholders. So this is a little bit of a contrast to number 1. They can act as fixed placeholders or unknown fixed numbers. So in number 1, A, B, and C, the variables in the relationships can be any number. But there are some relationships where we don't know what the variable is, but they cannot be any number. So for example, we can say that if we're given 5x plus 6 is equal to 21, x is not just any number. Let's go ahead and solve it and see. We subtract 6 from both sides, and that will go to 0. 21 minus 6 is 15. 5x is equal to 15, divide by 5. X is going to equal 3. Okay, x cannot be just any number. X will not vary. It is a fixed unknown number. Or we can say that x represents a fixed unknown number, to be more precise. Another example where we have 3x plus 5 is equal to 6x plus 7. Okay, x represents a fixed unknown number here as well. So x doesn't vary. Okay, so we subtract 3x from both sides. We can show this by solving for x. Subtracting 7. Negative 2, 3x, divided by 3. X is equal to minus 2/3. Okay, some fixed unknown number. The third role of variables. Variables represent a quantity that varies. Okay, and so we can do, for example, 3 times y is equal to some number f. Okay. In this one, y and f, well, y can be any number, can vary, and be any number. F can also vary, but not as much as y. Well, F can vary, but not in the same sense, but not in the full sense, like y. Can, because f depends on y. Another example. Well, for example, let's go ahead and put some numbers in there. Like, if we let y equal 3, then 3 times 3 is going to equal 9. Okay, so f is, which is equal to f. So f is 9 in that case. We could also let y equal 2. Then 3 times 2 is equal to 6, which is equal to f. Okay. And so f ends up being like any number, but it really depends on what y is. Y we can choose as any number. Here's a real life example. $10d equals p. Okay, so if D is equal to the number of dimes I have, sorry about that, and P is equal to the number of pennies. Okay, so 10D equals P as a relationship. 10 times the number of dimes is equal to the number of pennies. Number 4. Variables represent parameters. Or constants in the general form. Okay, what we have for an example here is the standard form for a parabola. Okay, so this is a bit more complicated than what we'll get to because this is like high school stuff. Okay, so the A, the B, and the C are variables that represent parameters. And they can vary. Okay, they're not fixed. They could be any number. So you can choose a specific number for them if you want. Y could be 2x squared plus 3x plus 5. Okay, you can choose specific numbers. But you can go and choose other specific numbers. So that could be anything. Now x in this case is a variable that represents a quantity that varies. Okay. And then another example could be slope-intercept form. For a line. Okay, y equals mx plus b. Okay, the m and the b are parameters. Okay. Number 5. Variables represent algebraic structures. We want to add, then they have a certain structure. So we're going to add 5x plus 2. I want to add that to 6x plus 4. Okay, they have algebraic structures. which means that I can't add the 2 and the 6x. Okay, there's a certain structure with it. So we want to add the like terms. 5x plus 6x plus 2 plus 4 equals 11x plus 6. Okay. So they represent those structures that you have for algebra. Okay. I can only add these two because they're like each other. They have that variable with them, so it represents that structure. Okay, the next part is I'm gonna go ahead and just review again. Okay, class, in this last section of today's video, we're gonna go back through some random examples of variables in certain equations, situations, expressions, and we're gonna assess whether they vary or do not vary. Okay? There's 5 types from the reading, but in the main takeaways for this section is we're only going to think about 2 types, ones that vary and ones that do not. Okay. So variables that vary or are fixed. Okay. Number 1. Situation 1 says 8 plus n equals 17. Go ahead and pause the video and see if you can decide whether this variable n varies or not. Okay, now that you've thought about that and resume the video, we can see that it can vary or not by solving for n. So if we subtract 8 from both sides, n is going to be 9. Okay, and because n is 9, n represents a fixed but unknown quantity. Okay, it is unknown until you solve for it. Okay, n is not one of those situations where it could be 1, 2, 3, 4, 5, or any number. N has to be a certain number to make the equation true. Okay, number 2 of 6. We got 6 examples. Number 2 is 3n minus 4. Okay, this is an expression. There's no equation to it. And because of that, we can't really solve for anything, and thus n represents a quantity that varies. With no restrictions on it. Okay. Number 3. P is equal to 6n plus 7. Okay. So since there's 2 variables on here, 6n plus 7 is not equal to a certain number as an answer. So it's not like a fixed quantity like number 1. So P is going to have n. So 3 is going to have n represent any quantity that varies, and P also represents a quantity that varies. So n represents a quantity that varies. With no restrictions. The other variable in here is p, and p represents a quantity that varies as well. Okay, p is not fixed and unknown. Now its restriction, it depends on what n is. Okay, for example, if n is equal to 2, then p is equal to 6 times 2 plus 7, which is equal to 12 plus 7, which is equal to 19. If n is equal to 5, then p is going to equal 6 times 5 plus 7, which is equal to 30, plus 7, which is equal to 37. Okay. Now p is ending up being like any number. P could be 19 or 37, but p really depends on what n is, whether n be 5 or 2. Okay. So both variables in there vary. Okay. Example number 4 is 6. If 12 times 4 is equal to 48, and 12 times some number n is equal to 4.8, then n is equal to 0.4, 0.4. Okay. This is a fancy way of saying that n does not vary. N represents a fixed quantity. Okay, it was unknown until they revealed it right here. Okay. N represents a fixed quantity. Okay, so it doesn't vary. Situation number 5 of 6. Ballroom A. A is a letter, like the ballroom in the Shepherd Union. Okay, the focus is A, that is a letter. Is this letter a variable? Okay, well, we call a literal symbol. Okay, a literal symbol. So in this video, letters could be used in math and literature or signage or anything like that. Those are referred to as literal symbols when they're like that. Okay, in general, all uses of letters. Okay, but in this case, if let's just say ballroom A, and I don't put it into any sort of expression or equation, A is just a literal symbol and is not even used as a variable. And so in number 9 on the homework, don't worry about that one too much because I'm not going to grade that. I think it's kind of a little over the top to think about letters as literal symbols and everything. What the most important part of this lesson is whether or not the role of the variable has a fixed unknown quantity as a role or a variable as a role. It could be any number. Okay. So number 6. we're thinking about 3n plus 4 being greater than 10. Now, what about the variable in this one, n? Okay. Can it vary or is it fixed? So let's go ahead and solve it for n and see what happens. So simplify. 3n is equal to 6 divided by 3. Not equal. N is greater than 6. 3n is greater than 6. So that means that n is going to be greater than 2. And in this case, n is greater than 2. So therefore, n represents a quantity that varies. Okay, and it has a restriction as long as it is not less than or equal to 2. It has to be bigger than that. Okay. For example, n can be 3, 4, 5, etc. And the inequality is still true. Okay. All right, so that's what we have for our variables little lesson. Please feel free to email me questions. You should be able to do the homework now. And I hope you have a great day.